Hello, everyone. So let's get the webinar started. Let me move some of my panels around and make my webcam smaller here. So hi, my name is Anthony Calderone. I am the Chief Technical Officer at SolidCAM. Looks like there's a good mix of resellers and customers in here. So if you are a first-time GoToMeeting or GoToWebinar user, I'm going to keep my webcam up the entire time. So I believe what everybody should see on their side is you probably don't see my screen sharing yet. So hold on, let me turn that on. So screen sharing. So now you should see my screen with my PowerPoint presentation, and then you'll also see at the top half of your screen is going to be the webcam of myself. So what you can do, if you have a big screen and you would like to be able to keep the webcam open the entire time, there's like a horizontal bar that's like 2/3 or 3/4 of the way up. That controls the height of the webcam. You can keep that like 3/4 of the way if you want to see me talking the entire time. If not, you can take that little bar and just drag it all the way to the top, and then you'll just see my screen sharing. And yeah, so it's up to you if you like to see the webcam displaying. So today we're going to talk about SolidCAM for operators. I assume most people here are SolidCAM users, and hopefully everybody has seen some information about SolidCAM for operators, but today we'll go over it. And I'm going to take this little panel and hide it the best I can because it's covering my screen. So before we get into actually showing SolidCAM for operators, let's talk a little bit about what a traditional CNC department looks like. So generally we have our CAM programmers, and we may be sitting in an office or we may be sitting out at the machine depending on the size of the company. Then as CAM programmers, we dump off the G codes usually to setup guys or setup people. Then the setup person sets up the machine, and it's usually passed over to operators to run our CNC. Now, of course, depending on the size of the machine or the size of the machine shop, sometimes the programmer, setup guy, and operator are the same person, and you program right out at the machine. But I think in a traditional sense of a machine shop, there's usually a couple layers here between CAM, the programmer, and the operators actually running the machine. Now we've done a little bit of analysis just to kind of have an understanding of like what ratios of CAM programmers to operators look like in a CNC machine shop. And basically what we kind of see is that 15% of machine shops are 1 to 3 CNCs in their facility. Companies that actually have 4 to 10 CNCs, they make up the bulk of the CNC of machine shops, at least from our customer base. And then we have about 25% which are in the 10 to 30 CNC range. And then we have customers that have greater than 30 CNCs. And I think everybody who's been in a machine shop can kind of agree with these numbers. I mean, in the bulk, most companies are going to have several CNCs. So 4 to 10 CNCs, or somewhere in the 4 to 30 CNC range is pretty much the general size of machine shops. What you do see is, depending upon the size or how many CNCs they have, it kind of stretches the ratio of how many CAM programmers there exist to the number of CNCs on their shop floor. So when we look at small shops, 1 to 3 CNCs, obviously we kind of have about a 1-to-1 ratio of CAM programmers to CNCs. And like I said, I think we have a lot of customers who are single operator, programmer, owner type of facilities that really have their own CNC, and it's 1 CAM programmer for each CNC. Then it kind of stretches to like 2 programmers to 1, 3 to 1, and 4 to 1. So basically what this kind of means is that the larger the shop gets, I would say the bigger the disconnect happens, or separation that happens between CAM programmers and the people on the shop floor. When you're a smaller company and you have 1 single programmer to like 1 or 2 setup guys, I think there's a pretty close relationship about what's going on. There's a really a lot of feedback back and forth. As you get into a larger shop or a company with more machines, the CAM programmer, when you're operating and programming for 5 or 8 CNCs, I think they're usually generally begins to be a little bit of a difficulty with the the feedback between the floor and the CAM programmer, just because you're servicing so many people and so many machines. So what's our goal with SolidCAM for operators? Our goal is to kind of break down some of those barriers and try to make a tighter knit between the operators and the setup staff on the floor and CAM programming. So and that's what we're going to kind of show here, a way where we can actually see everybody talking kind of about the same type of things in CAM, feed speeds, and how to modify programs, and how that can be easier with SolidCAM for operators. So why do CNC operators need SolidCAM for operators? Well, one, we provide a clearer picture for setup and prove outs. We have the ability to change minor G-code parameters like feeds and speeds and step overs and wall offsets. It can help prevent crashes, broken tools, and scrap parts. As you'll see, is really good simulation. So being able to see things ahead of time, you can help some of those things. This is the thing I most like, number 4, which is a stronger relationship between shop and programming. In my experience, looking, every time I've gone in the CNC machine shops, either, before I worked at SolidCAM, every time you see there's a strong relationship between and a good communication between the people on the floor and the CAM programmers. I feel like those people and those facilities do the most impressive type of work, and everybody's the happiest. So I think building a strong relationship between programming and the shop floor is huge. And this also gives a way to improve the skills of the operators and the people on the shop floor. And I think this gives a way to transition to programming. I think all of us who are CAM programmers here, we all started operating machines, right? So eventually, to be a CAM programmer, you're going to start at the shop floor. So with SolidCAM for operators, by being the same software as SolidCAM, it helps improve skills for somebody who's on the shop floor to be able to transition into programming. So here's a short list of benefits I'll kind of demonstrate today. So the CNC operator and the CAM program are using the same software with SolidCAM for operators. As a operator, we get to see exactly what the CAM programmer sees. It's not like a different type of interface or UI or a light product. It's exactly what we see in CAM. You can simulate step by step, operations by operations, tools by tools, which I think is really nice because it's kind of a way, at least my style of working, it's what I liked. The operator, we get to see the exact 3D data and parameters of the tools. This is, I mean, let's be honest, I think coming from a machine shop, I think one of the most biggest thing is setups of tools. And in today's environment where tools are getting more complex, especially mill turn and all the crazy like holders and this and that, being able to see the exact 3D representation of the tools is huge. As operators now, we can also view the roughing and finishing offsets directly inside the software. So instead of trying to guess what, if we're leaving 5 thou, 8 thou on the walls or the floors, as you learn a little bit about the SolidCAM for operators, we can see exactly what the CAM programmers programmed for each operation as you're going along and programming. So it's really cool to know if things are going to clean up and things like that. The CNC operator also has the ability, and these are, we'll talk about some of the licensing options, and these are basically things we can set up from the management of a machine shop if you want operators to do this, but the operator can edit feeds and speeds. They can edit things like step downs and step overs, and they can do that separately for roughing and finishing, which is really cool. And you can change your roughing and finishing offsets. So like if you decide, you need to leave a little bit more material for finishing, you can make those changes. And you can also generate G-code step by step for complex parts. Once again, I think if you're doing complex parts, I think a lot of people, like in my background, we have our new Hermley in our tech center. When you're programming 5-axis parts, especially the complexity of it, I've always liked being able to generate G-code in like steps as I'm going through my prove out. Obviously, if it's a short program, it's only 10 or 15 minutes, it's not that big a deal. But when we get, I think a lot of our customers are doing complex parts, they may take hours to do the prove outs. It's all personal preference, but you don't always have to just G-code the entire program and then try to run the entire G code, especially if you know you're going to be making feeds and speed edits and modifying and talking back with CAM. So with SolidCAM for operators, you can just generate G code step by step and kind of prove out on the machine as you go along, which is my style that I like to work. So let's do a brief live demonstration of SolidCAM for operators. As I said, I kind of suspect everybody here is SolidCAM users, so you're going to basically see SolidCAM just in a little bit different UI running outside of SolidWorks or Inventor. So let me minimize this. So here we have SolidWorks. So I'm gonna kind of pretend I got my CAM programmer hat on. So I am programming right now. Let's say I finished programming this part. So at the end of programming our part, what would we do? We'd probably run simulation. So I'm just gonna pretend to run some simulation. We have our roughing toolpath that does the roughing. Then it'll do the semi-finish. Blah blah blah. So as the last step of a CAM programmer, we review our toolpath, we review the program, we say if it's good or not. We generally would generate some tool sheet. So for instance, I have open a tool sheet for this. So in SolidCAM's tool sheets, we kind of have information about the machine, work material, number of operations. You can see there's some screen captures. We have information about the tool, so length of cuts. We have like little 3D images. So this is like our static tool sheet. And I think anybody who's familiar with SolidCAM knows that this can be customized and they can look very different. This is just kind of a basic, simple setup sheet in a PDF format. And we have like our list of operations at the end, which has like offsets and feeds and speeds, et cetera, et cetera. From my side, and I think everybody would agree with this, taking a static PDF, and that's usually the thing that we hand to the shop floor. We hand that PDF, we hand G code, and we say, here you go, run this program. There's a lot of disconnect there between what's actually happening in SolidCAM and what tools are happening and what the simulation looks like. And I mean, on some controllers, like the Hermle here, it does have like a little bit of a graphics check with even like some solid verify, and it's okay. I mean, it helps. From my side, I kind of feel like usually the graphics on the controllers are more there to stop seeing any weird movements that might exist in the code. That way, like as an operator, we have an idea what the program's going to do, but it really doesn't give a lot of good detail. You can't really see how the tool's engaging and what step overs and step downs look like. It's really like just kind of an overview. And this is the way we've always worked. We hand G code out to the shop floor, and we try to understand the code and what it's going to do by reading G code, which is from my side very difficult. So what do we have? We have SolidCAM for operators. So what happens with SolidCAM for operators? So there is a setting in SolidCAM, which I'd like to show everybody. So underneath the SolidCAM settings, CAM part, there is, under the closed CAM part section, there is a checkbox for prepare for SolidCAM for operators. And what this does is when the CAM part is closed, we make sure that we have graphic files for the stock, the target, and the fixtures, so that way when we load in SolidCAM for operators, we can see that. So you're going to see we're running outside of SolidWorks, so we're not going to see the native SolidWorks fixtures and targets and everything like that. So we need to just prepare these graphic models so that way we can see it in SolidCAM for operators. So we'll just close this file. I'm going to close out SolidWorks. And now I'm going to put on my setup or operator hat, and I'm going to pretend that I'm now going to I need to run this G code. So before running this G code, what we can do is we can open up SolidCAM for operators. We can open up the exact same part that the CAM programmer was using, where the CAM programmer could obviously make a duplicate of it. This is workflow permissions decisions that each customer needs to make. But I've now opened up, and you can see this here in our shop floor editor or SolidCAM for operators. This is the same part that we just had opened up in SolidWorks. We can go to the simulation. You'll see the same simulation starting to play. That was exactly what we saw just a minute ago. So this is a full SolidCAM running in a little viewer. You can see we have full access to Toolkit. So yeah, as I said, I'm assuming everybody here is familiar with SolidCAM and our existing SolidCAM users. So as SolidCAM users, you should be seeing this is the full SolidCAM. So you can see we go through each of the tools. We have our tool viewer. You know, we can see we can see what the tool is like. You can zoom, pan around, and rotate. You can go to all the parameters. You can see the default feeds and speeds for the tools. You can see the connections. A lot of people use the descriptions for things on the tools. And obviously, as we talk about things like mill turn, where tools are even more complex, you know, you have really the full view and picture here of how the tools are set up in mill turn, which is awesome. So instead of trying to just look at a static PDF and trying to assume how the tools are set up, you see all of it. We even have like machine preview. So I mean, in this example, we can even have machine preview. As everybody who knows SolidCAM, you can even move things around in machine preview. So this is the full SolidCAM. So SolidCAM for operators is full SolidCAM. You can see everything that we as programmers can see. And we do this from SolidCAM for operators. Obviously, the main thing that I think everybody should be taking away here is that we're not inside SolidWorks and we are not inside Inventor. So you're not going to create toolpath in SolidCAM for operators, right? Because there's no geometry, there's no CAD model to pick on, there's no fixturings, like geometrical data to create toolpath. It's a viewer. We can simulate, we can see things, we can go into the operations and browse anything in the operation. So, you know, as CAM programmers, you can kind of decide for the operators and setup people on the floor how much information you want to kind of, you know, give as an overview to the guys using SolidCAM for operators. And you can show them the operations a little bit. You can kind of give them, you know, let's be honest, like if you look at an operation here, what's the main things we would want to show somebody on the floor? We'd want to show them where they can see the default feeds and speeds. You want to probably show them where they can see like coolant, because this is, you know, something interesting. And then you could see things like in passes, and here you can see like step over, step downs, and some tolerances and things like that. And so SolidCAM for operators, so I'll just continue simulating this a little bit. So as you can see, we have the full simulation of SolidCAM. I can speed this up a bit. As the simulation progresses, you can teach the your coworkers on the floor how they can use things like stock and target comparison. I mean, this is like awesome. You know, you can actually, as you're stepping through the, we see all these, this is always one thing I think. As CAM programmers, we have amazing, fantastic graphics and tools to see what is happening as we're progressing through programming. You know, even just here, we have all these different colors for how much stock to leave we have. You know, we can see, where there's material, how much there's material. And as CAM programmers, it's like all this beautiful graphics and all these tools. And I mean, let's be honest, it's SolidCAM. I feel like sometimes we spend more development time on UI and graphics than we do on like toolpath, because in the end, you're trying, you can create toolpath, but you need to be able to understand what it's doing and the result of what it's going to be with machining the part. But when we go to G code, you like lose all of that. You know, it's like you just have straight XYZ movements, some tool change calls, and really as a person on the shop floor, you're very void of good data. I know as a person on the floor, I hated running other people's programs. I just didn't like doing it. Like as a person who knew how to run CAM software, whenever I ran my own programs, I knew exactly what was going to happen when I was out at the machine because I was the one who programmed it. I knew if I faced the top of the stock, that was first. I knew if I was finishing the top of the stock right away, maybe I was leaving material on the top, then I'd go around and do the outside. Like as I was doing my own, running my own prove outs, I knew what the program looked like. When it came to running another programmer's parts, you didn't know what was going on. So, you know, in the place I used to work where we use SolidCAM, I always put SolidCAM on a computer on the shop floor. So this way I could simulate and see what was going on in SolidCAM from another person's program. And, you know, I know some of our customers do have seats of SolidCAM out on the shop floor, but, you know, we could be honest here. If you're going to give somebody on the shop floor SolidWorks and the full SolidCAM, it could be a bit more intimidating if you're not familiar with using those tools. And it's not something, let's say, super casual that you could just, you know, maybe show somebody or one of, you know, in a quick session or something. But SolidCAM for operators here, it's pretty simple. I mean, the main tools are, let's be honest, open, closing, simulation, and G-coding, which is, you know, really even in our ribbon, you can see there's only a few options. As we know in SolidCAM, we have our ribbon in SolidCAM, which has lots of options, right? Because it's for creating operations, different types of operations. But here at SolidCAM for operators, we're trying to make it be just a little simple, casual, and easy for somebody to learn how to do things. Now, I have a couple things I want to highlight here on a simpler part, because modifying some things as a setup guy or an operator, I think is a really cool feature here. So let's say we got this part here, and the first thing we got is we have a face mill that's just going across the top of the stock and just cleaning off the top of the stock. Now, as you saw, there was no material being cut away on the top face because, you know, depending upon how you set up your parts, some people put their coordinate system at the top of their stock. They just face right to Z0, and then they kind of leave it for the operator to, let's say, you know, either adjust to put that face down in the stock a little bit, or they just assume the stock's going to clean up based on how the material was prepped. So if we think about this, a lot of times when we'd run like a face mill on something like this, we may adjust feeds and speeds a little bit. So we can see down here, we got a feed of 998 millimeters per minute. For people that are imperial and inch units, I apologize. I always try to do my webinars a little bit of metric and a little bit of inch. That way it kind of goes internationally. So here we got 998 millimeters per minute with a spindle speed of 5,800 RPMs. Well, what if we just modified that out at the machine? What if there's a little bit of chatter and we just like kicked up the RPM a little bit and modified the feed? Normally, as a operator, what are our choices? We could try to fix the G-code. So let's just say we G-coded this one operation. I mean, we could try to we could take the G-code and let's say, let's change the RPM to 6,200 and 6,210, and then we could go trying and changing the feed rates in the G-code. But obviously, as we know, manually editing G-code, that's not a nice thing to do because it never gets back into the source, which is SolidCAM. And if you G-code the part again, you lose that information. So what do? I mean, I know when we were in the shop, like a lot of times we would just have hand notes, right? So like on the setup sheets, as a setup guy, you would write on the operation by operation, okay, we change this feed and speed, blah, 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 blah. You make a list of notes, you hand it back to the CAM programmer and ask them to make those changes. Well, with SolidCAM for operators, we can kind of make these changes right away directly in SolidCAM. So let's say we want to actually teach our setup people or operators how to make changes for feeds and speeds. This is pretty simple. You open up the first operation. Let's just say we want to change the RPM. I picked a kind of goofy number because, as we know with controllers, you're always, when you do overrides, you always get like a non-round number for the most part. because that's just how the overrides kind of work. So I think it's kind of cool that you can literally type in the exact feed and RPM, and let's just say we typed in a 6,210 inches RPM and 1,021. Simple change. Calculate the operation. It was not difficult to change. G code. Now we have our new RPM and we have our new feed rate. So very simple change. I think this is something probably almost every machine shop is doing. Overrides of feeds and speeds. Very, very simple to do. Even something maybe as simple as like, pecking amounts for drilling. I mean, here's let's see, this is a straight drilling operation. Maybe this operation you wanted to turn it into pecking, and you wanted to be able to change some of the step downs or pecking or decrements amounts and things like that. So these simple things, which is the stuff that as operators we're normally changing, we can show our coworkers how to do this directly in SolidCAM. And in SolidCAM for operators, since it is the full version of SolidCAM, they can make those changes. And I'll talk a little bit after we get done this. There is some licensing. There is some parameter option, so we can limit literally just to feed and speed changes if that's the only thing you want to be able to do. Now, I also wanted to show another interesting feature, which I think is this toolpath. Yeah, this is exactly what I was looking for. So here we have a outside cut, and it cuts around the outside. Now, we see we have these little tiny posts that get stuck up on 3 of the corners. Now, the first corner there wasn't because the lead in and lead out extended tangent, and it cleaned up that chunk. So here we see these little slivers. Now, here, let's say it's pretty easy to see these slivers. So, but sometimes in CAM, it's a little hard to see these things. There can be little tiny nubs, and they're things that, let's say, we only see when we're out there running the machine, right? So like, it's pretty simple. When you're running the machine, you'll see this right away, right? And normally we also see these little types of, chunks because they bend away and they're there. In the virtual world here, these things don't bend. I mean, if the tool really kind of just came almost kind of tangent to this, the simulation would show it gone entirely, right? But we know in machining, if it's especially like aluminum, you might see that thing just kind of like bend away and then it's sitting there. And then later on, you might just plunge on it or something. So you have a simple thing here of just, as a CAM programmer, we made one pass around this. It's one pass, cuts around the OD just for roughing. If you would like to allow your operators to make some more advanced changes, it's pretty easy to do something like just add multi-passes. So like here in profiling, let's be honest, as we know from our statistics, most CAM parts, the bulk of operations in SolidCAM are eye machining, profile, pocket, and drilling. So those make up like 70% of all operations in SolidCAM, because even when we do 5-axis parts and stuff, you're still most of the time breaking it down into profile, pockets, drills, and things like that. And you leave 5-axis simultaneous toolpaths for like finishing like tapered walls and surfaces and stuff. So we as CAM programmers have the ability to teach our coworkers on the shop floor simple edits in profile, pocket, and drilling and eye machining, and they can probably do a huge amount of simple edits without them having to come back to us in programming to make these changes. So for instance, I just want to add a clear offset. So you teach your user, hey, there's the ability to just make a clear offset, and you can just cut an extra pass along here. We save and calculate this. I closed the simulation while I was running, and here you see we got toolpath. So this is the toolpath. We can go to simulation. Oh, I think I did something. I think I was doing something with the webcam at the same time. I was kind of trying to drag it out of the way. Okay, so here we have our 2 passes, and if we simulate this, now we can see we got a couple passes clearing away this material. And now we don't have those, those little nubs. And I see something here which I always think is nice to show the people on the shop floor. So I know, I think everybody who knows from running machines, air cutting is the worst, right? And when we're in CAM, we are, I don't know what the word would be, but it's really hard to, it's really hard to see air cutting in CAM software, right? Because we're simulating fast. When you're on the shop floor, this operation is taking, let's say, 3 minutes to cut around that outside. Well, we simulated here, depending upon the speed, it's super fast. So what I see here, just knowing this, if I restart this, we see the first cut along the backside is touching material. But then what happens on the right-hand side? It's cutting air. And I kind of like to point this out because as operators, sometimes it's very easy for us to be critical of the CAM programmers and be like, hey, I can't believe, this part, there's like air cutting here. Like, why did you do that? Isn't there just like, some way to get rid of that, or can't you modify the program? And of course, the answer is always yes. There is always ways to get rid of these things, but it's CAM software. Like, there's choices, and it takes time to do the most optimized program. So what I like about SolidCAM for operators here is that you start to see the same software as the programmer and the operator, and you can kind of connect and talk to your operators and explain this stuff. So like here, as an operator, I made a simple change. I'm like, I just want to add extra passes around it. Well, you see now as an operator, oh, well, technically, I didn't need extra passes on the right and left because there's not as much material. So as an operator, you kind of have to decide, was that an okay thing for me? Am I okay with it wasting a little bit of time air cutting? And if they're not, then you kind of got to go, then you got to go back to CAM programming and be like, hey, listen, I tried to make a modification here. I tried to add an extra pass, but now it's air cutting on the right-hand side. Could you optimize the program, which would be something like, just do one pass along the back wall, do one pass along the front wall, then come in and add that, then keep the pass that we have that cuts one pass around the entire thing. So what I like here is it brings communication. It starts to break down these things where operators, if you've never programmed in CAM, you wouldn't understand these things, right? Like, you just think like, oh, this is just, the software should just magically know not to do something. And depending upon, of course, being an iMachining person here, I would say if we used iMachining, we never have air cutting. And I would, so my first thing would be like, oh, if you used iMachining, this wouldn't even be a problem. But I'm practical. It's clear not everybody uses iMachining for everything. So there's options in the toolpath that may or may not give you the result of the toolpath you want. And the most perfect toolpath might take more time to do in CAM. Or maybe you just don't see it until you get out to the shop floor and you didn't think it was such a big deal. So I really like the fact that SolidCAM for operators is the full SolidCAM. We start to give the operator some tools that are the same tools we use as CAM programmers. And you start getting both yourself and the operators being on a similar page. You can start to understand some of the things that we go through as programming, and some of the programming choices you make as you program. And then they get to learn how to modify that. And I mean, I know from my side, I would love as a CAM programmer if my operator was like, hey, operation number 3 cuts around the outside. I saw you only did one pass. I tried to make it 2 passes, but it cuts air on the side. And could you modify that? Like, it's just such a nicer conversation than being like, yeah, we left some material in the corners and you need to go do something about it. So I like this idea that CAM and the shop floor guys running the machine, there's a tighter communication there. And let's see, anything else I wanted to show on this part? No, I don't think so. You know, once again, I mean, I guess I'll mention the, you know, the toolpath checkboxes. You know, these are also really, really cool just as a, you know, as an operator. Like I said, you know, the machines generally have like a graphics on them, which is just like this wireframe. It's cool, but usually if you G-code this entire program, what do you see? Just wireframe covering the entire toolpath. It's not so informative. But I mean, if I was running this program on the Hermley behind me, even if I G-coded out the full program, I would be clicking the checkbox next to each operation, and I'd be like, okay, this thing's gonna clean out the corners. Okay, this one's gonna cut on the inside. And by just turning on these checkboxes, you can see. I also see what the cycle times are. So I can see this first operation is supposed to take 32 seconds. Then the next one's supposed to take 52 seconds. Just having this software sitting next to the Hermley as I was running it, which it's just awesome. It really does help a lot. Let's see, I also want to do one last cool thing, which is showing a 5-axis program, because, you know, 5-axis is, let's say, one of the more, you know, complex things to understand reading G-code, right? I mean, pretty much if you're trying to read the G-code for 5-axis, like, good luck trying to understand. Maybe you'll understand the first like A and C move, but the actual movement, you know, it's kind of crazy to see. And this is something maybe the controller does a decent job, but if you look at wireframe for 5-axis, like, you can't really understand much with wireframe. The Hermley is pretty decent, which actually, you know, it actually has like the solid verify, so you can actually see how the tool's cutting around, but a lot of the controllers don't have that, so wireframe is not so cool. So being able to go into simulation here, actually see how the tool movements look like, and of course, as having full SolidCAM, what's the best thing to see? Machine simulation. So if you want to launch machine simulation, once again, full version of SolidCAM. This is not like a watered down something of SolidCAM. It is the same software. So as we see here, we have full machine simulation. So if, as the operator, you actually want to see your Hermley and what it looks like running this operation, you have it here in SolidCAM for operators. It's, from my side, it's a no-brainer. I mean, I think every one of our customers should have SolidCAM for operators. It really, really, really closes down barriers and stuff like that between CAM programming and the shop floor, and just it's worth so much more than trying to read G-code and understand what G-code is doing. So yeah, I think SolidCAM for operators is something every one of you should have. I think that concludes the main presentation for SolidCAM for operators. So let's jump back into the PowerPoint. So I mentioned this a little bit, that there's different licensing modes. So let's consider this like access modes. So we have 3 different modes. We have an editor, we have a simulator, and we have an editor lite. What's the difference between these? So this is kind of like decisions that we would want to make as the management of SolidCAM. So let me just make sure everything is still sharing. Yes, it is. Okay. In editor, we can modify and edit the operations. So this means we had access to everything. So being able to change like the wall offsets, clear offsets, step over amounts. You know, if you're doing 3D ball milling and you want to, you know, make the step over, you know, decrease it from 5 thou to 3 thou to get a better surface finish. In editor mode, you have access, or we give access to SolidCAM for operators for everything. You can change your tool settings, so like offsets, outside holder lengths, even diameters. You know, if you're using like regrinds and things like that, we can allow our, you know, the users on the shop floor to make those changes. You can change the part setup. So part setups is like where the part's actually located on the machine. You know, in the Hermley, it takes care of its full kinematics and everything. So you don't necessarily have to change your part setup for something like a controller like this, but still being able to move the part in the setup allows simulation to be more accurate. So this is something that maybe, let's say, until the operator actually sets up the machine, you wouldn't know exactly where on the table it was located. So we can give them the ability to just shift the part in the setup in SolidCAM. You have full simulation and obviously the ability to generate G-code. What do you get in Editor Lite? So Editor Lite is, I think this is probably the most beneficial one, because I think this is something that every user should have, which is you can view all the operations, you can change your tool settings, which also include your feed and speed. So basically, you know, the most important thing I think all of us do when running the machine is your feed overrides, feed and spindle speed RPM overrides. So that's probably the single biggest edit I think that every customer does, because the person on the shop floor just uses the overrides and adjusts it. So being able to just give that ability is the only like editing capability they have. They can view the part setup so they can see where it's at. They have full simulation. They can generate G-code, but the only editing they can do is feeds and speeds, basically. And then we have just a simulator mode only. So basically, let's consider this view. This would be like a read-only mode. You can view the operations, you can view the tools, you can view the setup, you have full simulation, you can generate G-code. So like, once again, I like, from my side, I like the ability to be able to program, you know, G-code operations by operations and run the program in that step by step, depending on how big it is. So in simulator mode, you're just getting read only and you can generate G-code. You can't edit anything, which could be something that, you know, let's say, I mean, I would say machine shops that are ISO or AS9100 certified, you know, let's say as an operator, you're not allowed to make changes at all. So only CAM programming can make changes, but generating G-code, it comes out the same way out of SolidCAM every time. So you may allow your operators to generate the G-code. And to end off with, I have one thing I want to show here, which is SolidCAM for operators right by the machine. So I think obviously everybody's getting the point that SolidCAM for operators should be installed on a computer next to the machine or out on the shop floor somewhere. To make this even more easy for users, we've developed a touchscreen kind of tablet version for this that uses Windows PCs. So I am going to modify my webcam a little bit to point down. And I am not a YouTube streamer with all my cool stuff set up, but I want to show this, and let me move my webcam around. Okay. So what I have here is a Microsoft Surface, and let me, all right, I'm gonna try and use this upside down, which is a little weird for me, but so what do we have here? So here we have a Microsoft Surface tablet. So this is a Windows PC, so this is important. So when I say tablet, we're not talking about Android or iOS, because SolidCAM for operators is the full SolidCAM version, right? So it's a Windows desktop product, so it needs to run on Windows because it's full SolidCAM. We're not making like a little viewer. This is full SolidCAM. So you can just go out and purchase a inexpensive tablet PC. I mean, we've even run this on like a $500 low cost tablet from Windows, because you're not calculating toolpath and doing stuff, right? You're just doing simple stuff. So in here, this is, you know, we've activated some simple touch stuff. So here you have, you know, you can see you're zooming, panning, rotating, you know, with your touch screen. It is still the same SolidCAM for operators. You know, in my opinion, I got, you know, the touch pens are really, really awesome now. So for like this Microsoft Surface, you know, I got you know, we just bought the Surface with the keyboard and the pen, and like really this thing is awesome. It is super portable. You can use the pen for your fine touching. You know, you have a full keyboard if you want to modify feeds and speeds. Honestly, even in Windows, touch is pretty awesome nowadays. I mean, really, you can make changes and operate SolidCAM pretty awesome with touch. I mean, you know, if we want to, you know, the biggest things you don't get with touch is kind of like a right click. So like I have, you know, I have like a right click option set up here on the pen. And I mean, you can see like running SolidCAM for operators with your finger is actually decent on these tablets now. You know, back in the day, Windows touchscreen devices were left a lot to be desired, but nowadays they're decent. They are really good. I mean, it's not a, you know, it's not as perfect as an iPad, but for what we're looking to do, I mean, it is very usable. You know, and if you use kind of the pen with it, the pen kind of gives you, you know, a little bit finer touch. And once again, it's the full version of SolidCAM, and you can make your feeds and speeds edits, and these devices actually last a really long time. I mean, this Surface tablet, I don't know what the battery life is, but like this, it's hours and hours. And we're not doing like toolpath calculations and heavy things. Okay, simulation might be a little bit heavy, but for the most part, you're not like running iterative simulations, right? If you're sitting out at the shop floor, you know, you're going to take the first set of tool changes, you know, the first tool, G-code that, simulate it, and with this, you know, with this like tablet device, it lasts hours. I mean, I wouldn't be surprised if it could even last a full day. And like a cool thing, I mean, I personally like the Microsoft Surface, just to kind of show a little bit here. You know, you can have a keyboard with it, which pops, you know, the keyboard pops on and off. So this is like a portable device. You know, I could see in a shop, you kind of maybe, depending upon the size of your company, I could see you having two different styles of working. Either you could have a full desktop or like a laptop with a monitor and everything sitting at each machine, or you just have this floating laptop, $500 laptop. I mean, I think this Surface was $800 or $900, pretty inexpensive. This thing you could just take to any machine you want in your shop. So, you know, this is something that could be shared by 2 or 3 operators, and you know, you just set up a spot in the shop for this to be docked at and charging, and you can use it wherever you like. And like I said, with the keyboard and the mouse here, you know, with the Microsoft Surface, it's pretty awesome. You know, you just come in here, make some feeds and speed changes, calculate an operation. You know, if you use like the keyboard here, it's got the little mouse and stuff, or it's got the little trackpad, generate G code. I mean, it's awesome. I mean, this is really, I mean, for even if you have a computer that's sitting maybe by every machine, this could be something that's even nice for, let's say, you know, the shop floor foreman or something like that, because you could just always have just a simple little laptop, and you can walk around to the machines, and if you want to know what's actually cutting in the machine, it is way easier to open up SolidCAM for operators and simulate and see what's going on. You know, if you're just kind of walking around the shop and you try to look in the machine that's running, you usually don't see too much, right? There's coolant splashing everywhere. It's hard to really get an idea for what you're dealing with. But if you have, you know, if you walk around with this little tablet, you could just, you know, open up the part file on the network, simulate it, see what's going on, and you know, as a foreman, I think it's awesome. Or as a machine shop owner, you know, you can just have this thing and just walk around with it, and you know, kind of see what's going on in the shop. So luckily, technology nowadays, Microsoft has really gotten awesome with these touchscreen devices and these ultra portables, and they're cheap, very cheap. Microsoft is making them, HP makes them. You can get these little devices like this super cheap. I mean, we went with Microsoft because I think I think the Microsoft is the most polished one, and it's, like I said, not that expensive. This is not a crazy expensive setup. It's not like you're buying like a $4,000 like touchscreen thing. Like I said, all in, I think this was like $1,000 with the keyboard and pen and everything. All right, let me close that out. Close that, and let me move my webcam back up. I apologize for the close up of my face. So yeah, that was the best thing I could do, was just taking the webcam and loading it on my monitor. So we'll summarize with just a few things before we get to some questions and answers. So what's the basic summary? We can prevent machine and cutting tool damage because as operators, we can see the full solid and machine simulations that we have. We can work way more efficiently because now our operators can make minor adjustments without the need to rely on CAM programmers, or just as operators, we can talk way more intelligently and on the same level with the same terminology as the CAM programmers. It's so much more nicer to be able to be like, hey, the wall offset, not in profile operation, blah, 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 you need to increase it. You're just talking about the same terminology as an operator when you're looking in SolidCAM. And you get the full setup picture. As an operator, we can see all the details of everything. We see the full tools, the full setup, how the stock is, where the home positions or work offsets are. You know, it's actually something I kind of forgot to mention, is that as an operator, you also see where the work offsets are. You can even go, you know, once again, talking to everybody who's familiar with SolidCAM, you have all the coordinate system and the coordinate system manager from SolidCAM, so you can see where all the coordinate systems are inside. And you can also eliminate, you can either eliminate or speed up your drive runs. So I think for some of us, when we run as, you know, when we run up a program, I think a lot of times we do step-by-step programming with drive runs. You know, we you know, either we don't put a piece of stock in the material and we just run it fully out at the machine, or we shift up all of our tool length offsets and just kind of drive run. Because once again, when you're looking at G code, you don't get a very good detailed picture of what it's doing. So with SolidCAM for operators, you can eliminate that drive run that we normally do. That's just trying, for us as operators, trying to get familiar with how the G code program is going to run. So to summarize, SolidCAM for operators is a great tool for all operators at machine shops using SolidCAM. SolidCAM for operators is bridging the work of the CAM programmers and the CNC machine operators, and this is greatly assisting and streamlining the machine shop process. Thanks for watching. And let me go switch over to see if there's any questions in here. Okay, so give me a second to, so if anybody, so I guess I'll give a couple minutes here. If anybody has any questions, on the right-hand side of the GoToMeeting panel, I think that's what you see as users, I forget. There should be a little section called questions, and there might be even like a little, you can like undock that little like pane. There should be like a little square with like an arrow on it, and that you can undock, and then you can actually see like a bigger list. And if you have any questions, you can just type it in here. So let's see. So okay, so Marco typed a question very early about seeing the jig or the fixture, and I think obviously I answered that, but just to, because you should have seen it. So as if we, I don't know if this one, if I had, did this one have the fixture on it? I think it did. Yeah. So when you go into simulation, you will see the fixture. So yes, so you see the fixture. Question about with the Surface Pro, do we find that an i5 is enough, or do we need an i7? We've tested it all the way down on, like, I think the Microsoft Surface Go, if I remember correctly, which is like not even the i series, and it worked. Like, I mean, if you're doing like 2.5D parts, like turning 2.5D, like non-5-axis, non-mold 3D heavy parts, like I think it's like a $400 for the Surface Go, and it worked. Question, just confirming it won't run on an iPad. Yes, that is correct. It does not run on an iPad. However, I would state that you could use an iPad if you were remote desktoping into a computer. You know, so if you did have a desktop computer or a normal computer with SolidCAM on it, you could just, you know, log into it with an iPad. But I don't know. I personally, I wouldn't recommend it. I don't see there's any point. I think it's better just to go buy a Microsoft Surface Go or something like that for $400 than to try to be using an iPad and all that stuff. Lucas asked a question, that I can create operations with automatic geometry. Okay, so the question is like this. Since this is the full SolidCAM, if you have an operation that doesn't necessarily need to redefine geometry from SolidWorks or Inventor, could you create those operations? I'm gonna give the answer and say no, but the reality is, the technical answer here is yes, you can actually do some newly created operations, because, like, for instance, I'll show it. There's not too many questions here. So let's just say we came back to that prismatic part with this outside cutting. In theory, because this is a full of SolidCAM, you technically could copy paste an operation and make some changes to it. So, like, let's say this one, we wanted to like change this operation to be 2. You technically can copy and paste the operation. You know, sorry, I kind of did Control-C, Control-V really quick. You can copy, you can paste. Now you get a duplicate operation, and now you have technically a second operation. You could even go into this operation and change a wall offset, change something. You could even say, you know what, I wanna go change this even to a different tool. So in the technical answer is you could potentially make operations. That's not what this is meant for, though. So my thing moving forward would be to anybody is, it's not what this is meant for. There is some potential depending upon the operations. You know, drilling, you technically could copy a drill operation and add like a smaller drill if you wanted to pre-drill it again or something, or come in with a smaller drill first. So you can technically create some operations. That's not the point. And that's definitely not something you would want to be showing your operators on the shop floor, that they should just be going and creating operations. I think if you're the CAM programmer, then yeah, totally. Like, as knowing how SolidCAM works, and as a CAM programmer, I could do it. But why? At that point, if I was doing it, I'd have my full SolidCAM. So I don't think you should be showing your coworkers that. But it is something you technically could do, but you know, there's not the meaning behind this. But since it's a full SolidCAM, we don't necessarily lock down some of that stuff. Can SolidCAM for operators convert parts from previous versions? I'm gonna say no. Once again, because you need geometry from the CAD system, either SolidWorks or Inventor, the answer should be no. But technically you can, depending upon the part you're working on. If you're just dealing with like a 2.5D part, profile pocket drilling, technically you don't, if the operations were defined, we don't go back to SolidWorks every time we calculate a toolpath. So in theory, not really, you don't need it. But when you talk about like 3D operations and stuff, we delete the facet models that we use for 3D calculation. So you're not going to recalculate 3D and 5-axis operations. So once again, the answer would be kind of like the other thing with making operations. Technically, you could do it in some limited situations, but that's not what it's meant for. And there's going to be lots of things that it can't do. So once again, CAM programming should always recalculate the part, open it up, close it from SolidWorks or Inventor, and have the part prepared. Is it suitable for SolidCAM turning? Yes, of course it is. And you know what? I apologize. I really should have had a mill turn or a turning part to show here. But yeah, it's a full SolidCAM. So mill turn, Swiss, whatever, it all works. Like it's, yeah. And yeah, if you would like to show your operators how to make simple changes to turning operations, feed speeds, if you want them to switch their CSS limits or something like that, you could absolutely 100% do it here. It's available, you can do it. Why does SolidCAM for operators not support assemblies? I'm not sure what that means, because we do. Remember, when you're in the, so you're not in the CAD system, right? So like, we do not take all of the bodies and things that you have in SolidWorks or Inventor and prepare that for SolidCAM for operators. We are showing the main components, which is stock and target. And when you go into simulation, if the CAM programmer has defined your fixtures, you will see them in simulation. But this is not SolidWorks, it's not a CAD platform. It's just, it's the things that we use for CAM. You can create a new one. Yes, you can create a new operation, Lucas was saying. So yes, in the end, you technically could create a new operation. We do not limit this stuff. So if you are an advanced SolidCAM user, you could do it. We've decided not to turn that stuff off. Although I do believe if you're in viewer mode or editor light mode, you do not have those options. So depending upon the licensing, you won't get those options to create ones. Can you use the full help guide from SolidCAM? Yeah, absolutely. I am. Let me just double check and make sure I can hit F1. So yeah, you can show your users that SolidCAM milling help is working. So here you go, face milling. I was in face milling. It opens up the help. So yeah, once again, SolidCAM for operators. It is the full SolidCAM. So yes, help files, everything. They are all installed and ran. And for anybody who has not installed SolidCAM for operators, it's not even a different installation of SolidCAM. It is just a licensing option, which I apologize, I should have mentioned earlier. Every seat of SolidCAM that gets installed has SolidCAM for operators installed too. So every person who's installed SolidCAM 2022 and on, you will see on your desktop SolidCAM for operators in the shortcut. So SolidCAM for operators gets installed with every seat of SolidCAM. If you want to install SolidCAM for operators for a machine on the floor, you're installing SolidCAM. It's the license that controls whether you have access to only it or etc. Is it possible to run channel sync? Yes, of course you can run channel sync. I don't know exactly what that last question was asking, so I'm not going to say anything. Let's see. Is there anything else we have here? No, I think that's all the questions. Let me just double check the panel. I think sometimes yep, no, there's any question. Let me just double check. Nope, nope, and no hands are up or anything. Great. So, well, everybody, thank you for joining the webinar. For everybody that's a SolidCAM reseller, I would say, please be showing SolidCAM for operators in your presentations and stuff to customers. It's I think it's a very awesome tool that I think any customer who has access to be able to put SolidCAM on the shop floor, it really can make a big difference. Show your customers that SolidCAM for operators is installed with every seat of SolidCAM. So if any of your CAM users want to have just want to understand how SolidCAM for operators works, it gets installed. It's the link there. So show them how it works and kind of explain a little bit about it. And for any customers, ask your, if you're on SolidCAM 2022, you have access to SolidCAM for operators. So SolidCAM for operators, I'm 99% sure it is accessible for any seat of SolidCAM that's running. So if you have SolidCAM installed on your computer and you have a license for SolidCAM, because you're obviously programming with it, whether it's milling, turning, mill turn, SolidCAM for operators will run. So you can, close your part out of SolidWorks or Inventor, and then open up SolidCAM for operators, your shortcut, and take a look and see what it is. Show it to your team on the floor. Show them what they can see. Ask them if they, if they would like it. And since SolidCAM for operators is the normal SolidCAM install, you can just go download SolidCAM, install it on a new computer, and I think you get a 30 or 60-day trial license with it. So, I mean, any customers who are interested in trying it, you already have SolidCAM downloaded. If you got a computer on the shop floor, go install it. You got 30 or 60 days to show your users and the shop floor people that they can use it. So all you got to do is just take your SolidCAM part file, and make it accessible for them to open. Because maybe I kind of blew past it, but you are opening up SolidCAM part files. So you're opening up either either PRTs, PRZs, internal CAM. Interesting note: internal CAM parts are accessible. The only problem with that is you need to have like SolidWorks installed on the computer, because reading in and out of SolidWorks files requires SolidWorks. So that is a limitation. But if I remember correctly, you do not even have to have, so if you're a bigger company and you got seats of SolidWorks network, as long as SolidWorks is installed on the computer, we can open up internal CAM parts. I don't believe it needs an active, you don't have to have SolidWorks open and to have an active license being taken up by that computer. It's just the reading in and out of of SolidWorks parts. We need the APIs from SolidWorks to be able to just get our data out of it. So yeah, I think if you can install SolidWorks on that computer without an active, used up network license, you can also deal with internal CAM parts. All right, well, thank you everybody for joining, and I wish everybody good luck with SolidCAM for operators.